y'all, this is Crazy Science Mom here today again for another awesome video on density. Everything is made of molecules. The more molecules it has, the heavier it is. The heavier it is, the denser it is. In order to find the density, you have to find two things. Its mass and its volume. I'm going to show you a simple experiment on how density works. Remember I told you that you need two things to find out density, mass and volume. Volume is the capacity, how much space the molecules take up. So there's 1 tablespoon of water in this one, 1 tablespoon of oil in this one. Same exact measurement. But we're going to measure the mass, the weight. So let's do that with the water first. So the water weighs 0.9 ounces and the oil weighs 0.8 ounces. So which one's heavier? The water is heavier, it's 0.9, and the oil is lighter, it's 0.8. So which one do you think will be heavier? Which one do you think will fall below the other? Let's see. Let me pour the water on top of the oil. So you see that the water is below the oil. It was heavier than the oil. So that means that the water is denser than the oil. We're going to see which of these float and which sink. I have a Diet Coke, I have a Coke, and I have a Coke Zero. Pause the video and you tell me which one you think is going to float and which one you think is going to sink. Okay, let's see. It's floating. Diet Coke floats. Coke. Huh. Coke sinks. Coke Zero floats. Let's see. So we got the Diet Coke and the Coke Zero. Those float, but the Coke sinks. Do you think maybe it's heavier? Well, it's the same volume. It is 12 ounces. 12 ounces and 12 ounces. So that's not the problem. So, I guess it's going to have to be the mass, right? Well, what's the difference between these? Why don't you pause and think about it? Let's see. This is Coke Zero. Zero sugar, right? This was Diet Coke. It's no sugar in there as well. And this one has tons of sugar. So that must be it. Sugar. Sugar water is denser than water. So this can has 39 grams of sugar. Do you know what that looks like? Are you ready for this? Yep, this much sugar. When you are consuming this can of Coke or anything with 39 grams of sugar, this is what it looks like. Remember I told you that the Coke sank because of the sugar. Well, here I have loads of sugar in here. Actually, I put corn syrup to make sure that this would work. And this has no sugar in it at all. So we're going to see if sugar water is really denser than regular water. You see the layering? The blue stays on the bottom and the red is on the top. So that shows that water is less dense than sugar water. Not only is sugar water denser, but salt water is denser. And we're going to do an experiment to show that. Here I got an egg and I've got fresh water. Let's see what happens. What do you think is going to happen? Pause the video. It's going to sink. Salt water. It floats. So we're going to see what happens if it's halfway full of salt water. And then I'm going to add some fresh water on top. So look, do you see what's happening? The egg is suspended in between the salt water and the fresh water. Hot air rises, cold air sinks. So hot air is less dense than cold air. Same thing with water. Hot water rises and cold air sinks. Let's see an example of that. So here I have the blue water that represents cold. Red water represents hot. So I'm going to put the cold water on top of the hot water and let's see what happens. Do you see the cold air is rushing down and the cold water is rushing down and the hot water is rushing up. And it's mixing. Why? See, the red and the blue are mixing together and that makes what? Makes purple. So now we're going to put the hot water on top and see what happens. Okay. Takes a little bit of time. So is anything happening? No. Why? Because the cold water is already at the bottom and the hot water is already at the top. So the cold water is denser than the hot water. So if you look over here, the mixture is purple water, and over here it did not mix. So I have taken the card out of both of them. So how many of you think that I can get the card back in without making a mess? Let's see. For our next experiment, I have my two wonderful assistants, and we are going to make the biggest liquid layer concoction that we can. So we're going to be using honey, corn syrup, chocolate syrup, Dawn dish soap, and water colored green, canola oil or vegetable oil. We have rubbing alcohol, dyed blue, and baby oil. All right. So, we're going to first, I'm going to have you pour in the honey. And you can put it straight down the middle, but the other ones we're going to have to be really careful with so it doesn't mix. But the honey is the first one. All right. And now we're going to have you do the corn syrup, and you can put it straight into the middle there. It's fine.
Ew.
Okay. All the way.
Next one.
Okay. And then you can do the chocolate. Yeah. You can do it straight down. Let's see what happens. You go all the way around. There you go. Oops.
Squishy.
All right.
It's gross.
This one, it's the
Dinosaur.
liquid soap. Hey, no licking the experiments. All right.
Whoa. This one's cool.
So then we have the water. So let's go ahead and start putting it down the side just in case. Don't lean it too much. I just want to make sure this is going to turn out good. Okay, now our next layer after the water is going to be oil. And this is going to not, for sure, not mix. Oil and water, they do not mix. You can shake, 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 and then it will definitely separate. And this is an example of immiscibility.
Wow.
Immiscibility is when you take two substances together and you try to shake them and they will not mix. They may mix for a time, but right away they're going to separate. Remember, the very first experiment we did, we saw that water is denser than oil. All right, so then we have the next one. Whose turn is it?
Mine.
Okay, so this is what we're gonna do. We're going to use a baster, okay? We're gonna squeeze,
Got a baster.
and then we're going to suck all that rubbing alcohol up,
That's
and then I want you to put it down the side.
Side.
Yeah.
Do it.
Oop. There we go. Because we definitely don't want this to mix. Do it slowly, just in case. There we go.
Why is it going on top?
Is it going on top? Oh,
Wait.
yes. Oh, you don't want to smell that. That's pretty nasty. All right.
Smells disgusting.
I can smell it from here.
Don't ever
Okay.
smell alcohol. Blah.
Okay, and then let's get another bit. And you want to do it again? Okay. All right.
Baby. Ew, it smells like baby.
Wait, let me see.
All right.
I love the smell of baby oil.
Oh,
like
that
baby.
looks beautiful. All right. Then
Baby powder.
go ahead and do the same thing with the next one. Yeah.
Oh.
Okay. You squeeze it, then you put it in the baby oil, then you let go. Okay. All right. Okay.
Wait.
My hands are cool.
Okay, ready?
Wow.
Oh, wow, look at that. It's going through each layer.
That's so cool.
Come
Wow. All right, so what we're going to do is we're going to drop some items inside and we're going to guess which layer it is going to fall in. Okay, let's start with the tomato.
Okay.
Oh, you ready? Okay, so where do you think it's going to land?
What do you think?
I think the soap. What do you think?
I think this.
You think the honey?
Yeah.
Okay, let's see. Go. Oh, wow, it landed in the soap.
Mine's right here.
Right on top of the chocolate.
Yeah, right on top of the chocolate. Okay, let's try this, the
Peanuts.
Peanuts.
Both?
What do you think? What do you think? I say oil. Oh, the green. Oh, no, it is the soap. Lands in the soap. Okay, what about your little, what about your toy, Elia, the little bitty toy? What do you think? Okay. Which one do you think? I'll say the chocolate. What do you think?
Chocolate.
What do you think? Oh my goodness, is everything landing on the soap? Wow. Okay, try that, the bolt.
No, I think this one's going to the honey.
Yeah, me too.
Me too.
Ooh, look at the bottom there.
Look at that.
Wow. Ooh.
It's frozen.
Cool. Oh, look at the bubble going up. The bubble.
Whoa.
Oh, wow, that's so good.
It looks like it's frozen.
Oh, my goodness.
Looks like it's frozen.
Yeah, like
Oh. Hey, what else you have? Anything else? Try the cap. The cap over there. Where do you think the cap is going to land?
I'm gonna say like right here.
The oil?
Wait.
Okay.
Do
Try
you want
it.
both?
Kind of, yeah, drop it like that. No, drop it on the side and see what happens.
Fill it up. Yeah.
Okay. Oh, here we go. Okay, so that looks like
Ew.
it was in the alcohol layer. That's in the alcohol layer. For our next experiment, we're going to have rubbing alcohol. I colored it green. Then the oil. Notice how the alcohol is on top of the oil this time because the alcohol is less dense than the oil. And here we have soap, and this is water. Okay, I'm going to put the soap in the water, and I'm going to put that on top of the alcohol and that oil, and let's see what happens. It switches. Everything switches. Soap was at the top, now it's at the bottom. The oil was at the bottom, now it's at the top. All right, so what we've done here is we're going to make the ultimate lava lamp. We have water, oil, and we put some drops. We put blue, we put red and green, and we have these Alka-Seltzer tablets, and we are going to see what happens. Are you ready, everybody? Let's put it in 1, 2, 3.
Wow. Bloop, 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 bloop. Bloop, bloop, bloop.
It's green.
It's green now.
So what's happening is
Whoa.
the Alka-Seltzer contains citric acid and baking soda. And when the two ingredients react with water, sodium citrate and carbon dioxide is formed. The carbon dioxide gas bubbles are formed. As the bubbles rise to the top, they take the color with them.
I'll stick my finger.
Do it.
Whoa. Wait.
Yeah, do
I
it.
just see green. I guess because of all of the different colors mixed together.
Can I stick my finger in there?
Sure.
Does
All
it
right,
feel
y'all.
weird?
Nothing.
Well, we thank you for watching. We ask you to like, comment, share, and subscribe.
Bye. Bye.